Okay, this is a overview of the Staying Alive program. So in Staying Alive, you're producing a simple video game, and let me just go ahead and I'll run my final solution here. So the game, the main game is in the main program is Staying Alive, and Staying Alive takes as input a game configuration file like hitchhiker.txt. Alright, and oops, well, that game didn't last very long. So the objective of the game, ooh, I died again. So it's, alright, it's a little hard to get started. It's kind of a defect, but the idea is wherever my mouse is, my player is attracted to it, and the further away I am, the faster I move towards that coordinate. So I kind of, as I get closer and closer to the mouse, I get slower and slower. And obviously, as you've seen, if I get hit by one of these asteroids, the game is over. And I get a score here for every increment of the game loop. I don't get hit by an asteroid, then I get a point. All right, so it's a simple game, but it's good practice. As you might imagine, all these different asteroids are objects in the game, and they're different level files. So that's Hitchhiker, that's the first level file. Oop, and it's going to be hard to, this one's very hard. Alright, once I get started, it might be alright. So there are a lot more asteroids in this one, so, oh, alright. You get the idea. So that's the idea of the game, and you can also play, there's one other one, Pac-Man game configuration file, and so this is kind of a reimagination of Pac-Man with the characters in the screen. But alright, so what do you need to know about the assignment? You can watch, there's some YouTube videos if you want to watch the solution of the game. You start by downloading the zip file, and I've given you sort of stubbed versions. You'll be developing 3 classes in this assignment that all cooperate to achieve your objective. StayingAlive.java is where your main animation loop, so the main thing that controls the game, will go in there. It will be responsible for reading in the control file, creating the player object. So there'll be one player object, so there's only one instance of this guy moving around the screen, and then there's some variable number of enemy objects, and so those are all the asteroids or all the Pac-Man figures, all the ghosts bouncing around. You've got to complete the code in the player class and the enemy class. And so player knows things like its location, its X and its Y, so those are things that are probably going to be instance variables in your class. It has a certain image file that it uses to display itself. It has things it can do like draw itself, update its position, see if it hits, if it's intersected in an enemy object, and then also print a representation of itself out to the console window. Enemy is similar. It knows its X and its Y. It has a X and Y velocity and a radius and an image file. And it also has this rotation angle. So if you recall from the video, right, the asteroids were rotating around, and so from each frame of the animation to the next, it needs to keep track of what its rotation angle is. And it's not, students sometimes get upset. I mean, it's not the most realistic thing because they're all rotating, exactly in the same way, but it's good enough. So just do it the way it's specified in the assignment, and if you want to do the extra credit, you can make it do whatever you like. Here's the format of the control file, and it starts off with the background image, the image of the player object, the X and the Y location of the player, the radius of the player. So everything in this assignment is in the unit box. So you're going to start bang on center. So in this assignment, you don't need to be setting the canvas size or the X coordinate, the X scale or the Y scale. We'll do everything in the unit box. Here's the radius. So all objects and intersection of objects, for simplicity in this assignment, we'll assume everybody's a circle, more or less. So even though the asteroids aren't really circles, we'll call them circles for the sake of example. And the speed factor determines how fast the player is attracted to your mouse position. So I'll show you. There's the assignment describes how you do that calculation. There are 6 enemy objects, and they have sometimes different images. They have different starting locations and X and Y velocities All right, and the end of these files has a bunch of comments, so you don't need to read in or parse these comments. So you just read in the beginning of the file, and then you just can safely ignore all this. But you can see I've got comments describing the exact format of the file. Your very first goal should be to read in this input and create your objects and then print them out. So you have to produce a program that produces some output on the console window. So you saw whenever I ran this, I got this output. And so your very first program, so I've made different versions of Staying Alive. So your first goal is probably to produce a program that does something like this. Oops, hitchhiker.txt. It just simply reads in that data file, parses it, creates a player object, creates an enemy object, and I've implemented the toString methods, but I haven't implemented anything else. Alright, so that's a good first phase of the program. And then what did I do in the next phase? Alright, I've opened up the draw window and I've implemented the mouse dynamics, and I can move my player object, but I haven't actually done anything with the enemies. Alright, so it's a game with no score and you can just play forever. So that's a good second step. Third step, I've created the enemy objects, I've added my scoring, alright, but I have no collision detection and I have no motion of the asteroids. And then step number 4, I've implemented the movement of all my things, but I haven't done the collision detection. And then the fifth step would be to finally do the collision detection, and then the assignment is complete. You can read about here how the dynamics of that attraction to the mouse. So you can get the mouse coordinates by calling standard draw.mousex and mouse y, and that returns a double in the unit box, so in the coordinate system of standard draw. And then you pass that in to the update position method. So you call this on your player object, and then the player object updates its location. All right, and here's a worked example of how you do that update. All right, as I note here, like higher speeds actually cause slower, so higher speed is actually slower, but that's just an artifact of like how I set it up. So, and if you don't know how to do the collision detection, you should go back to the lecture where I talked about classes and objects and look at how you detect whether two circles intersect or not, because that's essentially how you'll be doing it in this assignment. Other things, anything else I need to mention about this? I don't think so. So I'll show you just code really quick. You can't see that code. That's secret code. Don't look at that. All right, you're given the stub code. All right, and so here's the player class and the enemy class, and you need to come up with what the instance variables should be and what the enemy instance variables should be, and then fill in the bodies of all the methods. All right, and as you fill these in, as a general rule, anytime you have a public method in your class, you should put a comment at the top saying exactly what the method does, what its purpose in life is, does it take any parameters, and if so, what they are, and what does it return, and so on. That's just the good programming practice, because a lot of people, they don't really care what's going on inside update position. They just want to know, if I call update position, what does it do? So having a comment at the top of every method is a good idea. And then here's that main program that runs the simulation.